Okay, so where do conditional probabilities come up? They do come up in quizzes and they do come in silly problems. So let's start with this. We have this example from last time, two rolls of a die. All possible pairs of rolls are equally likely, so every element in this square has probability of 1 over 16. So all elements are equally likely. That's our original model. Then somebody comes and tells us that the minimum of the two rolls is equal to 0. What's that event? The minimum equal to 0 can happen in many ways if we get two zeros, or if we get a zero and if we get two twos, or get a 2 and something larger. And so this is our new event B. The red event is the event B. And now we want to calculate probabilities inside this new universe. For example, you may be interested in the questions about the maximum of the two rolls. In the new universe, what's the probability that the maximum is equal to 1? The maximum being equal to 1 is this black event. And given that we're told that B occurred, this black event cannot happen. So this probability is equal to 0. How about the maximum being equal to 2, given that event B? Okay, we can use the definition here. It's going to be the probability that the maximum is equal to 2 and B occurs, divided by the probability of B. The probability that the maximum is equal to 2. Okay, what's the event that the maximum is equal to 2? Let's draw it. This is going to be the blue event. The maximum is equal to 2 if we get any of those blue points. So the intersection of the two events is the intersection of the red event and the blue event. There's only one point in their intersection. So the probability of that intersection happening is 1 over 16. That's the numerator. How about the denominator? The event B consists of 5 elements, each one of which had probability 1 over 16, so that's 5 over 16. And so the answer is 1 over 5. Could we have gotten this answer in a faster way? Yes. Here's how it goes. We're trying to find the conditional probability that we get this point, given that B occurred. B consists of 5 elements. All of those 5 elements were equally likely when we started, so they remain equally likely afterwards, because when we define conditional probabilities, we keep the same proportions inside the set. So the 5 red elements were equally likely. They remain equally likely in the conditional world. So conditional on B having happened, each one of these 5 elements has the same probability. So the probability that we actually get this point is going to be 1/5. And so that's the shortcut. More generally, whenever you have a uniform distribution on your initial sample space, when you condition on an event, your new distribution is still going to be uniform, but on the smaller event that we considered. So we started with a uniform distribution on the big square, and we ended up with a uniform distribution on just on the red points.